In this lecture, we will learn how to design this PEB shade. So first of all, we go to design option, we go to steel frame design, and then click on view revise preference. Here there are various options, that is design code, multi-response case design, framing type. Framing type is, there are various options, SMF, OMF, SCBF, OCBF and EBF. That is SMF stand for special moment frame, OMF stand for ordinary moment frame, and similarly this SCBF, OCBF and EBF for example stand for eccentric braced frame. So all these definitions are given in the IS 800 2007 code. So as our case, we will go with OMF, that is ordinary moment frame. And to consider this, we need to change our response reduction factor also. That we will change in the load pattern definition that I will tell you after a few minutes. But here the importance factor is 1, seismic zone is zone 2, and consider P delta done. We need to select yes, and we are not ignoring the seismic code. And similarly there are various other parameters that you can check, and then left click on OK. As I will telling you that we have selected this ordinary moment resisting frame, so we need to go to load patterns. Under the case of ELX, we have chosen response reduction factor as 3, so that OMF is correct, ordinary moment frame. If this was a SMR, that is special moment reduction frame, then we need to enter response reduction factor R as 5. Basically, response reduction factor is the factor by which we reduce the earthquake forces. That is, if our earthquake forces is divided by 5, then it is reduced a lot as compared to if we will divide it by 3. So we left click on OK here. One more thing that I like to notice here, that we need to go to load patterns here, and under ELX case you will see that we have entered the top story as story 1 and bottom story as base. That is for height calculation or time period calculation. What the software will consider the top story as story 1 height. So we need to check what exactly is the story 1 height level. As we know that this height is 5 meter and this height is 7 meter. So we need to enter story 1 or whatever story height is 7 meter. So what we need to do here is that we need to go to edit stories and grid systems. Here we can see that there are only 2 stories, that is story 1 and base. We can left click on quick add story, and then left click on modify story, show story data, and then here we can enter height as 4 meter and the total height is now 7 meter. And then we can left click on refresh view, and then left click again on OK, and then again on OK here. So here we can see that this height is unchanged, that is 5 meter, and this height is unchanged as 7 meter. If you will do something wrong, then this height will automatically change, so you need to cross check here. After that we need to again go to load patterns, and then again select this load, and then enter top story as story 2 here. So with this simple steps, we can change the height of the structure for the seismic load calculations. After that we need to go to design, steel frame design and view revise preference. That this data we have already entered here. So first of all we need to do the analysis here. We check whether there is any instability. There is no instability here, but we can see excessive deflection here. If you will see here, you will see that 1303.745 mm is deflection on the minus Z axis. So this type of instability can be removed by changing this bracing section. Before that we need to do the design here also. This optimization that we will do in the next lecture, but before that we need to go to design, steel frame design. We have selected IS 800 2007 here, and we need to start design check. So this is basically the contour here. That is, if the structure is showing red, then it means that utilization factor is greater than 1, and then it means that the member is failed. If it is magenta, then it means that the utilization ratio is between 0.9 and 1. If it is yellow, it means that the utilization ratio is between 0.7 and 0.9. Similarly for green and similarly for blue. So here you can see that each and every type of member is available. Blue member is also available, in which the design margin is very high. Yellow member is also available, in which the design margin is very optimal. Similarly, we have this red members here, that is the members have failed. If for example you will left click here and then right click, you will see that the software is not designing because it is class 4 section. Similarly, if you will left click and right click here, you will see that the utilization ratio is 0.794. So it means that under the loading condition, the 80% strength will be utilized and 20% will be like a safety factor here. And we can left click on overrides here also. So whatever if there is any local override for a particular member, then it will be visible here. So we left click on OK. Similarly, we can also left click on details to see the design calculations. So software will provide you all the data. It's up to you to check and cross check with your manual calculations that whatever software is doing is correct or not. I don't want you to follow garbage in garbage out approach. That is, some people like whatever software is doing is correct or whatever we are doing is correct. No, you have to cross check all the calculations and all the arrangements manually, and no software in this world can beat the good engineering judgment. So here basically our next step should be to optimize the members, and whatever members are failing or whatever members are having excessive deflection, so we need to change the arrangement of those members. So to change the arrangement, we will do in the next lecture, that is how to optimize the steel structure for the particular set of loadings.